In this video, I will discuss the difference between 12-factor apps and microservices. First, I will describe what are 12-factor apps. Then I will describe what microservices are and the difference between the two. And then I will conclude with how both can help you in developing applications. Okay, so first of all, what are 12-factor apps? Well, 12-factor apps are applications which adhere to the 12 principles under the 12-factor methodology for building software as a service applications. The methodology was presented by Adam Wiggins back in 2011. It consists of 12 principles that are designed to help developers build scalable and maintainable applications. Okay, so what are the 12 principles? Well, the first principle is codebase. One codebase tracked in revision control, many deploys. This is the principle of having a single codebase that's tracked in a version control system that allows for easier collaboration among team members and ensures that changes can be tracked and tested, and the ability to deploy multiple instances of the same codebase, ensuring that what is deployed is consistent against environments. Now, principle 2, dependencies. Explicitly declare and isolate dependencies. This principle emphasizes the importance of keeping dependencies separated and isolated. By declaring dependencies explicitly, developers can ensure that the software will work the same way regardless of the environment it's running in. Now, principle 3, config. Store configuration in the environment. Because storing configuration in the environment allows for greater flexibility in deploying software. It also ensures that the software can be easily configured for different environments. Now, principle 4, backend services. Treat backend services as attached resources. This principle emphasizes the importance of keeping backend services such as databases or message queues treated as attached resources that the application relies on and separated from the application code. Principle 5, build, release and run. Strictly separate build and run stages. This principle emphasizes the importance of separating the build, release and run stages of software development. By doing so, it's easier to manage changes and ensure that software is deployed consistently. Principle 6, processes. Execute the app as one or more stateless processes. This principle emphasizes the importance of using stateless processes which are easy to scale and maintain. By using stateless processes, developers can ensure that software will work consistently regardless of the environment it's running in. Principle 7, export services via port binding. This principle emphasizes the importance of using port binding, which allows services to be accessed through a well-defined API. By using port binding, developers can ensure that services are consistent and easy to manage. Principle 8, concurrency. Scale out via the process model. This principle emphasizes the importance of using a process model that allows for easy scaling of the software or applications. By using a process model, developers can ensure that software is scalable and can handle high traffic as it scales. Principle 8, disposability. Maximize robustness with fast startup and graceful shutdown. This principle emphasizes the importance of ensuring that software applications can be easily started and stopped without compromising its stability. By ensuring that software can be easily started and stopped, developers can ensure that it's more robust and can handle failure more gracefully. Principle 10, dev production parity. I believe I pronounced that wrong, but it's keep development, staging and production as similar as possible. This principle emphasizes the importance of keeping development, staging and production environments as similar as possible, because by doing so, developers can ensure that software is tested in a consistent environment and will work the same way in production. This principle also states that code written should be deployed to production as quickly as possible, which therefore means that story lead time should be as short as possible. It also implies that the people who write the code should be the ones deploying and running and monitoring the applications in production. Principle 11, logs. Treat logs as event streams. This principle emphasizes the importance of treating logs as event streams that can easily be analyzed and monitored. By treating logs as event streams, developers can ensure that software is more easily monitored and debugged. Principle 12, admin processes. Run admin/management tasks as one-off processes. This principle emphasizes the importance of running admin and management tasks as one-off processes that can be easily executed and monitored. By doing so, developers can ensure that software is more easily managed and maintained. Okay, now, what are microservices? Well, microservices is an architectural approach to designing, architecting, and developing applications. The microservice approach involves breaking down business activity processes into smaller, independent services that are responsible for a very specific business domain activity. These services can be developed and deployed and tested independently of each other. Compared to that of a monolithic application, microservices offer several business benefits, including better time to market, improved scalability, and increased flexibility. By breaking down an application into smaller, independent services, development teams can work on each service simultaneously, speeding up the development process and allowing for faster release cycles. Additionally, because domain activities are broken down into their own independent services, developers can choose the right tool for the right job, allowing for diversity in the service and technology used, which can improve innovation and performance. Okay, so what are the differences between 12-factor apps and microservices? Well, the 12-factor app is a methodology for building applications, services that are portable, scalable, and easy to observe and monitor. Microservices, on the other hand, is an architectural approach to breaking down business activities into small, independent services, allowing for scalability, optimization, increased innovation, and quicker time to market of features. Now, conclusion. Both 12-factor apps and microservices are valuable tools for building scalable and maintainable applications. While they are different, they can be used together to create a robust and flexible architecture. If you decide to follow our microservice approach but don't adhere to the 12 principles of 12-factor apps, you may encounter several issues that can impact the scalability, maintainability, and observability of your application. For example, if you don't store configuration in the environment, principle 3, it can be difficult to deploy and manage your microservices at scale. This can result in configuration drift, where the configuration of your production environment differs from your development environment, leading to inconsistent behavior and bugs. Additionally, if you don't treat backend services as attached resources, principle 4, you may encounter issues with scalability and availability. Because if a backend service is not treated as an attached resources, as an attached resource, scaling it up or down may require additional development work. Finally, if you don't treat logs as event streams, principle 11, it can be difficult to monitor and debug your microservices. Failure to treat logs as event streams can make it difficult to rapidly and accurately diagnose issues when they arise. By following the 12 principles of 12-factor apps when building microservices, you can ensure that your application is portable, scalable, and easy to observe. This can help you avoid common issues and ensure that your application is maintainable and efficient. When following the 12 principles of 12-factor apps but not using the microservice architecture approach, the resulting application could be a monolithic application. Monolithic applications can face several challenges that microservices are designed to address. One of the primary drawbacks of monolithic applications is scalability. Because all the application components are tightly coupled, it can be difficult to scale individual components independently. This can lead to the need to scale the entire application even if a single component requires additional resources. This is expensive and wasteful. Another drawback of monolithic applications is that they can be difficult to deploy and manage. When all components are tightly coupled, it can be difficult to deploy changes without affecting the entire application, which leads to longer testing cycles and dependencies on other teams, which can slow down time to market. Overall, when following the 12 principles of 12-factor apps, they can help you to ensure that applications are portable, scalable, easy to observe and monitor.